So this is the second part of my study of angling for Zander. Part 2, the results. So first of all, here I plotted out a histogram of the number of Zander caught per session over the 40 sessions. Remember, I've already said approximately an average of 4 were caught in every session, but wide variation. 4 depressing sessions caught nothing at all, and one marvellous heady session of 4 hours I actually caught 14. And the distribution is skewed towards the lower numbers, hence the average is around 4. What are my variables? Well, we usually talk about dependent variables, the things that we're going to try and predict from other variables, or DVs. So just going to concentrate on 2, number of Zander that I caught per rod per hour, because although I usually fish 3 rods and usually for 4.5 hours, it varied a little bit. So this keeps it on a constant scale, the number of Zander caught per rod per hour. And I also noted the total number of bites in a session and similarly could compute the number of bites per rod per hour. Because maybe some days I just wasn't on such good form and would miss Zander more than others. So bites might be more accurate. And these are the variables I use to try to predict the DVs: the barometric pressure, the air temperature at the start of the session. I didn't have a water thermometer, so it's air at the temperature at the end of the session. So the statistical results here are mostly computed using the excellent free software called JASP. That's the link where you can get it and download it for free. And here are the results, some simple correlations between the variables. All a correlation is a number which indexes the strength of the relationship between two variables, between two things. It can go from +1, where the entities are completely positively correlated. As one goes up, the other goes up in a straight line relationship. And it gets weaker and weaker until there's a 0 correlation. There's no relationship at all between our two variables. And then moving in the negative direction until there's a -1 relationship. The two variables are perfectly related, but they move in opposite directions. So as one increases, the other decreases. So we can see at the start, Zander and bites are very highly correlated. The more bites I had, the more Zander I caught per rod per hour, almost perfectly correlated. Similarly, the air pressure at the start and the end are almost perfectly correlated. If it was a cold evening and night, it remained cold by the end. But our key bits of interest are the correlation between Zander and temperature. And we notice there are moderate, mid-ranking positive correlations, 0.6 between Zander caught per rod per hour and the air temperature at the start, and a similar correlation with the air temperature at the end. Also, the same sorts of relationship when I explored it using bites with temperature at the start and the end. This is a simple scatter plot with a line of best fit for the relationship between the number of Zander caught per rod per hour and the air temperature. And I could have done it with the ending air temperature, this is the start, or with the bites and both the temperatures, and the relationship would have looked pretty similar. It's a moderate positive correlation as we saw, and the points follow a fairly regular linear relationship. This is the line of best fit. One way to test how important these correlations are is to see if, given the number of observations, they could have occurred even if the true relationship between these variables was non-existent, they had no correlation. You express that with a probability. The probability of getting a correlation this large or larger, if there was no relationship, is very small, less than 1 in 1,000, about 1 in 1,000, around about 1 in 1,000. By contrast, the relationship between pressure and Zander was close to 0, slightly negative, and you could easily get that result that different from 0 if there was no true relationship. And similarly, bites and pressure also showed no relationship. And just to show graphically the relationship between the number of Zander caught per rod per hour and the atmospheric pressure in millibars, there's no relationship. It draws a line of best fit, but there's no relationship at all. The data are a sort of cloud. The correlation was close to 0, as we've seen. It's actually slightly negative. So the correlations tend to show a clear relationship between the number of Zander or the bites and the temperature, but no relationships between the Zander caught, the number of bites, and the air pressure. I also did it a different way using so-called Bayes factors. We'll just briefly talk about those, an alternative way to look at the data. So a Bayes factor is a simple number that runs from 0 to infinity, expressing the weight of evidence for one hypothesis, which is usually known as HA or H1, relative to another, usually known as H0, usually a less interesting hypothesis. So we're comparing two hypotheses. And a Bayes factor is actually a change. It's a change in the weight of evidence after the data had been gathered compared with that before the experiment for those two hypotheses. And so a Bayes factor of 1 reflects no change in the weight of evidence. So Bayes factors, it's a complicated looking formula, but it's actually pretty straightforward. This is the odds, the ratio of the probabilities or likelihoods of one hypothesis relative to another prior to the study. And this is the odds, the hypothesis relative to the other after the study, after the data D have been collected. And so the thing that converts the odds ratio before to the odds ratio afterwards is the Bayes factor, denoted BF10 or sometimes BFA0. So this is how much the odds have increased for the ratio of these two hypotheses from before to after the study. So bigger numbers indicate stronger evidence in favour after collecting the data of HA. And some people have suggested, well, these numbers, what's important? There are a number of tables like this, but this is one of the more well-used ones. If you've got a Bayes factor of 100 or bigger, that's decisive evidence in favour of hypothesis A relative to hypothesis 0. In the range 30 to 100, very strong evidence, going down round to 1 when there's no evidence at all in favour of one way or the other. And as the numbers get smaller below 1, these are increasingly strong evidence in favour of H0 rather than HA. So we can look again at our data. The relationships between Zander and the air temperature have Bayes factors between 30 and almost 200, so strong or decisive evidence, similarly with bites. But the evidence for the relationship between the Zander court and pressure, or bites and pressure, these are less than 1. These numbers, they're well below 1. If we look back, between a tenth and a third, substantial evidence for hypothesis H0, i.e. that there is no relationship between the number of Zander court and the atmospheric pressure. If we look at the Bayesian correlation, is for those data we've just seen. This is imagining before the experiment, we've said there's no correlation, but we're not sure. So it could range anywhere between -1 and +1. Then after the experiment, we have this decisive evidence with a Bayes factor of nearly 200 in favour of there being a positive relationship, and it estimates the correlation at 0.57, and this is the possible range of values with 95% confidence between a 0.3 correlation and a 0.77 correlation. So clearly strong evidence that it is greater than 0. So what are the limitations of this study? It's a single study of a single species by a single angler, me. The bites measure, well, of course, I might have included bites where I didn't catch the fish, which were from another species. Although actually over the 40 sessions, I think I caught 3 other fish in total. 2 bream, interestingly, which don't normally eat dead fish, but they did, and 1 pike. So I didn't obviously record those as Zander. So in general, I think the bites were definitely Zander, and they have a very characteristic kind of bite. Finally, I was a bit skimpy on the measurement with air temperature and pressure. I didn't want to carry lots of gear down to the lake. So I actually used the BBC weather app, and it would have been better to use a water thermometer and a physical barometer. Would have given more precise, more localized measurements. But the relationship was strong with the temperature measured this way, so they appear to be reasonable measures. So in conclusion, I think this study shows quite strong evidence that increasing ambient air temperature does make it easier for an angler to catch Zander at least, and it's presumably because of the increased water temperature on days with high air temperature. There was no clear evidence at all in this study that barometric pressure has any influence on an angler's ability to catch Zander. Thanks for listening.